Hello everyone. In this video we're going to be solving an exponential system. We have a to the power ln a equals b to the power ln b and a minus b equals 1, and we're going to be finding the a and b values. When you look at the first equation, the obvious conclusion is a equals b, right? Alright, now let's go ahead and check what happens with that. If a is equal to b, and now if I replace a with b here, we get b minus b equals 1, which is 0 equals 1. And you're like, what? This is impossible. Then there are no solutions. Let's check it out. So here's what I'm going to do. I'm going to go ahead and set x equal to a to the power ln a and y equal to b to the power ln b. And then notice that here, since we have the natural log of a and natural log of b, a and b both have to be positive in order for those functions to be defined. All right, let's see what we can do with this. Since we have a variable in the exponent, it makes sense if we ln both sides. So ln x from here is going to be ln a to the power ln a, and this implies ln x equals, you know, this is a power, so you can move it to the front. It becomes ln a times ln a, which can be written as ln a squared. Okay? And by the same token, ln y is going to be ln b to the power ln b, and then from here, ln y can be written as ln b quantity squared. Great. Okay, so now we have these two equations, right? And what do we know? Our first equation gives us that x equals y. So we do know that x equals y. And let's see what this implies. Then if x is equal to y, then ln x should equal ln y, right? Okay. And this gives us the following. Ln x is ln a squared, and ln y is ln b squared. So we get this equality as a result. And this gives us two solutions, or two conclusions we can come up with. Either ln a is equal to ln b, which implies a is equal to b. But we already talked about it. It's impossible. If a is equal to b, then a minus b cannot equal 1, right? So that's just trash, throw it away. Or if two numbers, think about it, like two numbers squared are equal, so kind of like a squared equals b squared, then you can do difference of two squares and write this as ln a equals negative ln b. In other words, if the square of two numbers are equal, either the numbers are equal or they're opposites. Okay, now so we're going to go with this because that's the only thing we have. This one is gone. So this is kind of interesting, don't you think? ln a is equal to negative ln b. Let's go ahead and explore further. So ln a is equal to negative ln b. What is that supposed to be? So we can write this negative as negative 1 times ln b. And obviously we can just move this over here, make it a power. And this is the power of properties of logarithms. We can write this as ln b to the power negative 1. But b to the power negative 1 just means 1 over b. Make sense? ln 1 over b. So we got this result, ln a does not equal ln b, because that would imply a equals b. That's impossible. But ln a can equal ln 1 over b, which implies a is equal to 1 over b. Or you can also write this as a times b is equal to 1, right? Okay, so we got this result, but what is that supposed to mean? It means that we got an equation for a and b, and we also have another equation we can use, which is a minus b is equal to 1. We haven't used that yet. So let's go ahead and use it. So we also know that a minus b is equal to 1, along with a equals 1 over b. Now we can solve this as a system. Let's go ahead and solve it. And this solution actually is going to have an interesting flavor. Okay, let's see what happens. You probably already guessed. I'm going to replace a with 1 over b here, and that's going to give me 1 over b minus b is equal to 1. By the way, a and b are not interchangeable because their difference is 1, so you can't really interchange them. We're going to find the b values from here anyways. So let's go ahead and multiply both sides by b. 1 minus b squared is equal to b. Put everything on the b side. B squared plus b minus 1 is equal to 0. As you know, this is a quadratic equation and it has two solutions. What are they? B can be written as negative b, negative 1, plus minus the square root of b squared, which is, by the way, this b and that b is different. B is the coefficient of b in this case, but it's kind of confusing, I know. Anyways, 1 squared minus plus 4ac, so that's going to be 5. Okay, and that gives us the golden ratio, right? All right, a problem with that golden flavor. So here's the thing. We can split it up into two solutions. B can be written as negative 1 plus root 5 over 2, or b equals negative 1 minus root 5 over 2. Now, here's the problem. At some point, we said that, hey, a and b both have to be positive, right? Okay, so the second solution actually violates that rule, because negative 1 minus root 5 over 2, obviously, clearly, is less than 0, right? Hopefully. So we're not going to be able to take that. But the other one, the other solution is okay. So discard this one and take the first one. So again, like I said earlier, a and b are not interchangeable, so this is a unique value for b. We only got one solution. So what happens if b is equal to that? We can either use a minus b is 1. Let's use that. A minus b is 1. And we know that b is that. So let's see if we can kind of subtract it. But instead of subtracting, you can just go ahead and add that to both sides. And that's going to give you a. A is equal to 1 plus negative 1 plus root 5 over 2. If you make a common denominator, you get a 2 plus negative 1, which is 1. And this gives you 1 plus root 5 over 2 for the a value. So our a, b values are the following. We got for a 1 plus root 5 over 2. And for b, we got 1 minus, not 1 minus. So I should probably write it, I don't know. Maybe write it as root 5 plus 1 over 2. And the other one as root 5 minus 1 over 2. So they're kind of conjugates in this sense. And notice that when I subtract a minus b, I'm getting 1 because the square root of 5 cancels out. And when I multiply them, I'm getting 5 minus 1 divided by 4, which is equal to 1. It's kind of like two numbers whose difference is 1 and whose product is 1. Great, let's go ahead and take a look at the graph. I just wanted to share with you this real quick. And I believe I gave you a sneak peek of this right yesterday. So we have the following function. The function that I was asking about was y equals x to the power ln x. It's an interesting function. Let me tell you why. First of all, I think somebody said in the comments that it kind of looks like a parabola. And yes, it does, but it's not a parabola. It's a really weird graph. Let me tell you what is interesting. If you draw any horizontal line, and this is going to intersect the curve at 2 points, and if you look at the x coordinates of those points, you're going to realize the following. If one of them is m, the other one is just going to be 1 over m. Why? Because these 2 points are going to give you the same x to the power ln x values. So it's kind of interesting, I find it. Any horizontal line you draw, look, check the x coordinates of the points. They're always going to be reciprocals. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.